Okay. So in products of vectors, in our first part we talked about one famous type of the vectors, that is scalar product. And in the second part we are talking about the vector product, or that is known as cross product. Cross product, or it is also known as vector product. Why vector product? In case of cross product of the two vectors, if we have two vectors just like A and B are the two vectors, and if theta is the smaller angle between them, just like this, this is vector A and this is vector B, and this is the smaller angle between them, then the cross product of two vectors is denoted by A cross B. We read it as vector A cross vector B is equal to product of magnitudes of the two vectors. This is magnitude of vector A, magnitude of vector B, and sine of the smaller angle between them, sine of theta. But you have to remember here, cross product of two vectors is basically a vector quantity. It is equal to basically a third vector. Let me mention here, third vector is C vector, which is equal to product of magnitudes of the two vectors and sine of the smaller angle between them. And in order to represent the direction, let me write here a unit vector C. So cross product of two vectors is having magnitude as well as direction. The direction of the cross product of the vectors is given by this unit vector C. We'll be talking about it in detail. So you have to remember, cross product of two vectors is a vector quantity. It is having magnitude as well as direction. Okay. So in case of the cross product of two vectors, you have to remember the cross product of two vectors is equal to product of the magnitudes of the two. So it is magnitude of A, magnitude of B, represented by this, or by simply this, and sine of the theta between them. And don't forget to mention here the unit vector. This unit vector gives the direction of the resultant vector. Now firstly let's talk about the direction of the resultant vector in case of cross product of the two vectors. Let me take here a plan. Okay. And the two vectors. This is O, small a, represents vector A, vector B, and this is the angle between the two vectors, theta. So my students, in case of the two vectors, the cross product of the two vectors is equal to the product of magnitude of the two vectors and sine of the smaller angle between them. But as per their direction is concerned, the direction in case of the cross product of the two vectors is given by one rule that is known as right hand thumb rule. Yeah. According to this rule, if the curvature of the fingers gives the sense of rotation of the two vectors, then thumb gives the direction. So according to this rule, if we are multiplying A with B, then the third vector will be like this. This is unit vector C. Or if we are taking the two vectors in the same plan, but this time what we are doing, we are multiplying B with A. Yeah, like this. So here in this case, what will happen? If we are multiplying second vector with the first vector like this, so direction of resultant will be, yeah, it will be like this. This is unit vector C. So remember, in case of cross product of the two vectors, the resultant vector is perpendicular to the plane. Yeah, in both the cases. Whether you are talking about A cross B or B cross A, it is perpendicular to the plane containing the two vectors. But the difference is, in case of A cross B, it is in this direction, upward. In case of B cross A, it will be in the downward direction. So remember students, the direction of A cross B is given by right hand thumb rule, According to that rule, if the curvature of the fingers gives the sense of rotation of the two vectors, then the thumb, which is perpendicular to this plane containing the two vectors, gives the direction of the resultant. Or its direction is given by right hand screw rule. Exactly. If a screw is held perpendicular to the plane containing the two vectors and the screw is rotated in the sense in which direction we are going to multiply the two vectors, then the sense of rotation of the screw gives the direction of the resultant. Yeah, in that case it is also perpendicular to the plane containing the two vectors. But one difference is there. Just now in our previous lecture we talked that A dot B is equal to B dot A. That means dot product is commutative. But that is not true in case of the cross product of the vectors. Cross product of two vectors, we can write it like this. A cross B is not equal to B cross A. Why? Because it is clear from the figure that A cross B is, its product is like just like this, and B cross A, yeah, they are perpendicular to the plane, but they are acting in opposite directions. However, we can write A cross B is equal to, yeah, minus times. Minus times, because this C and this C are equal but acts in the opposite direction, minus times B cross A. Yeah. Okay. So, in cross product of the two vectors, the resultant vector is perpendicular to the plane containing the two vectors, and its direction is given by, yeah, right hand thumb rule, or second is right hand screw rule. Yeah, with the help of these two rules we can calculate the direction of the resultant vector in case of cross product of the vectors. Now there is one part of your question, that is the geometrical meaning in case of cross product. Geometrical meaning in case of cross product is equal to. Okay, so in order to understand the geometrical meaning of the cross product of the vectors, let us take two vectors. It is vector A, okay, O small a, and let me draw here another vector, O small b, it represents vector B. Let's take theta as the angle between the two vectors. So in order to explain the geometrical meaning, what we will do, we'll complete the parallelogram. Okay, we will draw a vector parallel to this vector A. Similarly, from here we will draw a vector parallel to this vector B. Yeah, this is vector A, this is vector B. So from this B now I will draw a perpendicular. Let me draw a perpendicular BD on vector A. Okay. So do one thing, join this B with A. So in this triangle, in triangle ODB, right angular triangle. So ODBD, BD by OB is equal to BD by OB, yeah, perpendicular by hypotenuse, that is sine of theta. So BD will be equal to OB. OB, that is magnitude of B, B sine theta. Yeah. So, can you tell me A cross B is equal to, yeah, A, B sine of theta into unit vector N or unit vector C. So, in order to get rid of that, let me write here, yeah, mod of A cross B is equal to A, B sine theta. Yeah, mod of A is equal to OA. Very good. And B sine theta. B sine theta is this time as BD. Yeah. So OA into BD. Yeah. That is equal to area of parallelogram. Yeah. Base into altitude. So magnitude of cross product of the two vectors. Geometrical meaning. Magnitude of cross product of the two vectors is equal to area of the parallelogram. Or we can write it, you will divide and multiply this equation by 2. What we will get? So this is 2 into 1 by 2 into OA into BD. So half of OA is base, BD is altitude. Half of base into altitude will give us area of triangle. Okay, so that is twice area of triangle. So remember students, always the magnitude of cross product of the two vectors is equal to area of parallelogram, or it is equal to twice area of triangle. And remember one more equation in terms of the diagonals. Yeah, this is one diagonal, this is second diagonal. In terms of the diagonals, product of magnitude of the two vectors, this cross product of the geometrical meaning of the cross product of the two vectors is equal to 1 by 2 into, yeah, it is d2 multiplied by d1. Yeah, mod of d2 into d1, where d1 is this larger diagonal and it is equal to a plus b. d2 is this, it is equal to a minus b. Yeah, or in some books it is written as minus 1 by 2 into d1 cross d2. Yeah, this is the geometrical meaning. Geometrical meaning of the cross product of the two vectors, the magnitude of the cross product of two vectors is equal to the area of parallelogram, or it is equal to the twice area of the triangle. Okay. So the related question to this cross product of the vectors is, let's talk about some of the special cases. One special case in case of the cross product of the two vectors is, let's talk about collinear vectors. Collinear vectors. In collinear vectors, we'll be talking about the parallel or anti-parallel. Yeah, in case of parallel vectors, theta will be equal to 0. In case of anti-parallel, theta will be equal to 180. So cross product will be equal to A cross B is equal to product of magnitude of the two vectors AB into sine of how much? 0 into unit vector C. Since sine of 0 is 0, so my students, remember always cross product of two collinear vectors, whether they are parallel or anti-parallel 180, so it is always equal to 0. While in case of perpendicular vectors, the cross product is equal to, if theta is equal to 90, yeah, the vectors are perpendicular and the cross product between the two vectors is equal to A cross B is equal to, that is A B sine of 90 into unit vector C. Yeah, that is equal to A B sine 90 is 1 into unit vector C. What is the function of this unit vector? Yeah, it gives the direction of the resultant vector. So it is clear that the direction of the resultant vector is perpendicular to the plane containing A cross B. Okay. In terms of rectangular unit vectors are orthogonal unit vectors, that is I, J and K, I cross I will be equal to. This is cross product between two collinear vectors, that is equal to mod of I, this is mod of I, this is sine of how much? Yeah, sine of 0. Since mod of I is 1, mod of I is 1, sine of 0 is 0, so that is equal to 0. So remember here, I cross I is equal to J cross J is equal to K cross K, and all the products are equal to 0. Why? Because these are collinear. Yeah, collinear unit vectors. What happens in case of I cross J? Yeah, that is mod of I, mod of J into sine of how much? 90 into unit vector C. Don't forget it. This is 1, sine of 90 is 1 into unit vector C. It will give the direction of the resultant vector. So I cross J, cross product of I and J will be a third vector. Yeah, The direction of the third vector is given by this unit vector c, which will be, according to right hand thumb rule or right hand secret rule, that will be perpendicular to the plane containing I cross j. What is the vector? That is perpendicular to the plane containing I cross j. Yes, 100% right. That is I cross j is equal to k. Yeah. So similarly, my students, can you tell me j cross I then will be equal to j cross. Since last time I talked about a cross b is not equal to b cross a, because cross product is anti-commutative. Here I cross j is equal to k, so j cross I will be equal to minus k. Yeah, you can remember all the products with the help of this simple diagram. This is I, this is j, and this is k. If we are traversing the loop in clockwise direction, so my students, what will happen to it? In clockwise direction, the products are taken as positive. In anti-clockwise direction, they will be taken as negative. So I cross j is here equal to k, j cross I, k cross I is equal to j, I cross j is equal to plus k. Similarly, I cross k is equal to minus j, j cross I, just like this, j cross I is equal to minus k, whereas I cross j is equal to plus k. So all the products can be calculated with the help of this simple diagram. Okay, in terms of Cartesian coordinate system, the cross product of the two vectors. Yeah, cross product of two vectors. If one vector A is equal to AXI plus AYJ plus AZK, and vector B is equal to BXI plus BYJ plus BZK. So A cross B can be calculated by a simple technique. We have to take the vector A, components of vector A, then cross components of second vector, vector B. Well, Bx, By and Bz are the components of vector B. Or there is a simple technique which you have to use in your future classes, in your future questions also. So A cross B, the simple technique is you will take here a determinant mode, yeah. So write down the three rectangular unit vectors I, J and K. Do one thing, write down the coefficients of vector A, coefficients of I, J and K for vector A. That is, this is AX, this is AY, this is AZ. Yeah. Similarly then, coefficients of I, J and K for vector B. This is Bx, this is By, and this is Bz. Now you can operate this determinant either by any row or by any column. This is row number first, row number second, row number third, column number first, column number second, column number third. Okay, let's operate it by row number 1. What is the first element? Okay, it is I. Now think about this. Cancel the row and column in which I exists. I is in row number 1. I is in column number 1. Oh, okay. What is remaining there? It is AY, AZ, BY, BZ. Cross multiply them. So it is AY, BZ, left diagonal, minus this diagonal, minus AZ, BY. Okay. Then there is second. This is J. So put a minus sign here. There's a formula for that, why to do it. So neglect the row and the column in which J exists. It is row number 1, column number 2. Here AX, BZ minus AZ, BX plus K into, yeah, K. Now it exists in row number 1, column number 3rd. So neglect this part. So here remaining elements are AX, BY, cross multiply them, AX, BY minus AY, BX. So students, this is the required answer for cross product of the two vectors. By this technique we can calculate the cross product of the two vectors. And here the simple formula is minus 1 raised power I plus J. For putting the sign, I is number of row, j is number of column. So similarly here, minus 1 raised to power, number of row is 1, number of column is 1, 1 plus 1 is 2, minus 1 raised to power 2 is plus 1. Similarly here, minus 1 raised to power 3 will be minus 1, and so on. So this is the required answer. Okay, thank you.